Okay, so yesterday we learned how to write equations of exponential and linear if we're given a table, right? Now, there's a little problem that we're going to deal with when it comes to exponentials. Linears, we're not going to worry about it. We're always going to be able to find that zero value. But what if I have an exponential equation, and let's say I'm not given that zero term? How do I find out A to go into my formula? And then to even go further than that, what if I'm missing some terms and I only have two terms? Say I only have 1, 4 and 4, 256, but I'm told that it's exponential. How do I come up with the formula for that exponential function? Well, that's what we're doing today. So, there are two methods. There is a division method and a substitution method. I will say that absolutely the division method is way easier. So that's the method I'm going to focus on. If you want to read about the substitution method or you want me to show you the substitution method, I can. But most of you would probably prefer the easier method anyways. Am I right? Okay. The substitution method, by the way, is the same as the substitution method that you learned when you learned systems of equations, where you get one letter by itself and then in the other equation you substitute in for that letter and solve. That is the substitution method that I'm talking about. Okay? All right. So, starting right here, I have 2 points. So in my XY table, I have the point 2, 4, and 5, 7. They're missing some terms, aren't they? Now, it's hard to come up with the other terms in that XY table because I know nothing about this exponential equation. All I know is that it's exponential. So, what I want you to know is we're going to use this formula, the y equals ab to the x, the same one that we used yesterday. And we're going to start off with the first point, plugging in x and y into this equation. Because if I'm given an ordered pair, aren't I given x and y? Yes? So if I plug x and y into here, what's going to go in for y? 4 equals ab to the what? Second. And if I did the same thing with this point, here's my x, here's my y, I would have what? 7 equals ab to the fifth. Now, in order to use the division method, you are going to want to write the two equations, one on top of the other, but you are going to want to write the one with the higher exponent on the top. Okay? Because if you write the one with the higher exponent on the bottom, you're going to end up with negative exponents and it gets a lot more complex. So if I were to list these with the one with the higher exponent on top and the one with the lower exponent on the bottom, that's what I would have. So? Now, here's the division method. There's my division sign. And I'm going to pretend like this is a fraction. Now, it does bug me a little bit because you don't really have an equal sign in a fraction. That's kind of yucko. But I'm going to treat these as individual parts. So 7 over 4, what would that equal? 7 divided by 4, 1.75. Equals, what happens when I have a over a? Cancels. And what happens when I have b to the fifth over b to the second? You have b to the third. Can I solve for b pretty easily here? How do I get b by itself? Cube root it. Or if you want to think back to our rational exponents, you could raise it to the 1/3 power, the reciprocal, right? But that's the same thing as taking the cube root. Do I need to worry about plus or minus or anything? No. So those cancel, and I need to do the cube root. That's what your calculator should look like. I know you can hardly see that because it's glaring, isn't it? Oh, come on. Give me a good angle here. Cube root. There we go. Trust me that it's a cube root. It's a cube root of 1.75. Now, when I hit enter, am I going to get a decimal? Yes, because I'm putting in a decimal, right? I get, what does it say up here? Keep 3 places past the decimal at every step. So 3 places past the decimal, that would be 205, and that 0 means the 5 stays a 5. So I have 1.205 is equal to B. So far, so good? Now, from yesterday, I have to remember what 2 letters do I need to write an equation? I need B and I need A. Well, I have B. How do you think I find A? Plug it in where? Either of these 2 equations. So I would pick the one that has easier numbers. Either one is going to get you the same result, but I would pick the one that has the smaller exponent because it's going to be easier to deal with, right? So I'm going to say 4 equals A times B. What am I putting in for B? To the what power? Second. So you notice I haven't cleared my calculator. Let's square it without clearing it. How do I do that? Well, try just hitting your squared button and it'll automatically type in answer squared. What does that answer thing mean? We talked about that the other day. It's taking the previous answer and squaring it. So I have 4 equals 1.452 A. What am I going to do? Divide by 1.452. Do I need to use the rounded off form? Whoops, don't want to divide by A. Do I have to use it, or can I just do 4 divided by the previous answer? Whenever you can use that previous answer button, it maintains some accuracy. So whenever you can, use it. It also saves your fingers from having to type in all of those numbers. So what do I have? 2.7544. So does that mean it's 2.754 or 2.755? 754. So now that I have A and I have B, my equation is y equals 2.754 times, hang on, this is going to drive me nuts. I'm going to write it sideways because I hate having to split. Y equals 2.754 times, what's my B value? 1.205 to the x power. And that's what my equation looks like. It will have ugly decimals in it. That's just the nature of it. Okay? Questions there? Does that method make sense? Would you like to see that method again, or would you rather I show you the substitution as an alternate method? Same one? Okay. So, let's jump down here. 3.1, 5. What's that going to look like as an equation? Remember, that's the first step that we did up here. What's it going to look like? 5 equals a b to the 3.1 power. And that's ugly, but we'll see what happens with it. And what's this one going to look like? 9.7 equals a b to the 6.8 power. All going to be like this in what way? Decimals? Very well could be. Yep. Okay, so if I wanted to use the division method, what am I doing? I need to write the 9.7 one on top, don't I? Oops, sorry, that's equals. My bad. 5 equals a b to the 3.1. You okay with that so far? Where do I start now? 9.7 divided by 5. 9.7 divided by 5 is 1.94. Equals, what happens to the a's? Cancel. And then b, how do I find out that exponent? 6.8 minus 3.1. What do I have? 3.7. Now, can I take the 3.7th root of both sides? I don't know. Let's see. 3.7. That's not what I was looking for. It will let me take that. Will your calculator let you take that? It will? Fantastic. And I get 1.1961. That's going to round up to 196, or round to 196. And that's my B value. Now, what if my calculator won't take the 3.7th root? Is there anyone whose calculator won't let them take the 3.7th root? Speak now or forever hold your peace. Otherwise, I'm going to assume that your calculator is just fine.
Wait, did you run this number?
Which ones? The 196? 1961. You have to look at the 4 digits. The 1 is the 4th digit right there. And because that's not 5 or higher, it keeps the 6 before it a 6. So 196 is what I have after my decimal. Okay? We okay with that? Okay. If for some reason my calculator couldn't take a 3.7th root, because it's kind of funky, I could raise both sides to the reciprocal, which would be 1 over 3.7. 1 over 3.7. So if I took that 1.94 and I raised it to the 1 over 3.7, I get the same number. So that's an alternate way of doing it if your calculator won't do that crazy index on a root. All right, I got B. What do I do now? Go back and find A. Which equation should I plug it into? Doesn't matter, but 5 is probably going to be a little bit more reasonable because it's got a smaller exponent. So 5 equals A times B, which is 1.196, to the 3.1 power. Now, how can I use my answer button to not have to round this off? I already have the 1.196 not rounded off on my calculator screen. How do I raise it to the 3.1 power? Just hit your caret button or your to the button, and you should be able to use the previous answer. Okay? When I say caret, I mean this. I think that's actually the official name of it. Little arrow pointing up. I call it the to the button because every time I press it in my head I'm saying to the, like 5 to the 4th. Makes sense to me. So I have 5 equals 1.742A. And now what am I going to do? Divide both sides by 1.742. And on my calculator, if I don't want to use the rounded off version, I do 5 divided by the previous answer. And I'm left with 2.8697. That's an interesting one to round off. I have to look at the 7. Let's see if I can point exactly. There's the 7. What's going to happen because of the 7? That 9 has to go up, doesn't it? Well, if that 9 goes up, then the 6 goes up. So what does it round off to? 870. Now, some people will ask me, is that 0 really necessary? Well, if I'm looking for 3 digits past the decimal, that 0 is actually part of the rounding that I'm looking for. Okay? So that's what shows me that you're not just skipping out on the fact that there are digits there that are rounding up. So go ahead and give me that so you have your 3 digits. So what's my equation? Y equals 2.870 times what? 1.196 to the what power? X. That's my equation. Okay. Now, you could actually do this with any 2 points. Any 2 points, as long as they don't have matching X or matching Y values, could be on an exponential graph. Do you want me to show you another one, or do you think you're pretty good? You're pretty good? All right. Sounds good. Happy studying.